In this video, I'll be showing you the design and schematic for an audio booster and VU meter. First up is the audio booster. To get our positive and negative rails of a negative and positive 4.5 volts from a 9 volt battery source, we use a common technique using two identical resistors in series, creating a voltage division, as shown here. We then put capacitors in parallel with our resistors to create a more stable voltage across the resistors. This will create a positive 4.5 on the left and a negative 4.5 on the right, and a common ground in the center. For our positive input into our op-amp, we will tie that directly into our ground. For our negative input, we use our VN, which in our case is going to be our music, goes through a 4.7 kilo ohm resistor and into the negative rail, as long as it splits off and goes into a 50 kilo ohm potentiometer, and which goes into our output. This creates what's known as a gain. To get our gain, we put our 50K over our 4.7K ohm resistors, which creates a 10.6. What is good in this circuit is that we can adjust our 50 kilo ohm potentiometer from 0 to 50, so we can essentially create a gain from 0 to about 10.6. For our V out, which is our output here, it's going to be our negative gain times Vn, which will give us a boosted Vn to essentially create a larger and smaller volume. Now let's examine the schematic for a VU meter. The VU meter is used to give a visual image of the voltage level coming out of the audio booster. What is essentially happening is the volume combined with the increases in the volume of the music control the LEDs. In this diagram, we see the audio booster and the voltage supply from earlier, which the output of the audio booster is tied directly into pin 5. For the LEDs, we tie them in pins 1 and 10 through 18, which is then tied into positive 4.5 volts as seen. For pin 2, we hook that directly into our negative 4.5 volts, and pin 3 to our positive 4.5 volts. Pin 4 is hooked directly into our common ground. To create the adequate current, we hook pins 6 and 7 together, which is fed through a 1K resistor and into ground. The last pin, pin 9, is used to change the mode, which is hooked into pin 3 in our case, to give a good visual representation of our voltage. Now, finally, a working VU meter. What you see before you is a working audio booster and our left and right channels to feed into our headphones. For our common earbuds, what you can see is that as the volume goes up, our LEDs will go up and down. But if we were, say, to switch them to our Beats headphones, we're going to have to increase the volume due to how much the Beats draw, and it doesn't give us a good representation as what our little earbuds did. Thank you for watching my video on a VU and audio booster.